Every time a fan isn't starting, the first thing we do is call an electrician. However, the problem-causing material is just a small electric component, capacitor. When a potential difference is applied across a capacitor, the electrons from the battery move to the negative terminal of the capacitor, while an equal number of electrons are drawn away from the capacitor towards the battery. Therefore, this causes an imbalance of charge in the capacitor, with one plate being negatively charged and the other being positively charged. This imbalance of charge causes a potential difference in the capacitor, and when this potential difference becomes equal to the potential difference of the battery, the capacitor is known to be fully charged. However, when the access to power supply is lost, the capacitor comes to rescue. The capacitor supplies the charge it has stored, and therefore this is known as the discharging of the capacitor. To understand the function of a capacitor, a water reservoir is a very simple example. Just as a water reservoir stores water from the rain, a capacitor stores charge from the battery. Now you might wonder, if both a battery and a capacitor can store charges, then what's the difference between them? I can store charge using an electric field. I can store charge using chemicals. That's why I can live longer. This is a capacitor. It has two electrodes, the anode and the cathode. The anode is the positively charged plate and the cathode is the negatively charged plate. In between there is an insulating material which prevents the charges to pass through. The structure of a capacitor is somewhat similar to a sandwich, the loaves of the bread being the electrodes, the anode and the cathode, while the filling being the insulating material. To find out which capacitor is better than the other, we check the amount of charge stored by a capacitor for a particular value of voltage, which is also known as its capacitance. Experiments show that as you increase the voltage across a capacitor, the amount of charge stored by the capacitor also increases. Therefore, we can come up with the formula Q is equals to CV. Now you know about capacitors, so I don't think you are going to call an electrician again.